The purpose of this video is to demonstrate when there's an eulerian path and when there's an eulerian circuit, or when there's both or neither. So first let's think about what is an eulerian path. So we'll talk about paths first. So path means we want to transverse, go along every single edge of the graph once. So if I start here, and if I traverse, I got stuck. I can't get back to those other two edges. So that one didn't work. Well, does that mean it doesn't work? Maybe I didn't start in the right spot. Maybe if I start here. Oh, that didn't work. Let me try again. Okay, so I just found an eulerian path. And this is a very small graph, so it's hard to just say, oh, just try to find one. So there are more rules that go with, or guidelines that help you determine if there is an eulerian path or not. So I'm going to first think about what the degree is. So the degree is the number of edges either coming in or going out, and this way we don't have directions. So the degree of that vertex is 2 because there's 2 edges connected to it. That one is also 2, 2. This is 1, 2, 3, 4, 5. This one is 2, 3, and 2. So this has, I'm going to say this graph has an eulerian path. And I know that, well, I know it because I found it, but really you know it because there are exactly 2 vertices of odd degree. So this vertex and this vertex, and that also tells me where I have to start and end. So you can start at either the 5 or the 3 and end at the other one, but those have to be your starting and ending points. And if you really think about it, odd because once you go back to it, if it's not even degree, there's no way to get back out of that vertex. All right, so now let's think about an eulerian circuit. So I'm going to say this graph, well, an eulerian circuit means that the starting and ending point are the same. I don't know if I just said that right. The eulerian circuit means it's a path that starts and ends in the same spot. So this eulerian path I just found that started at 5 and ended at 3, that is not a circuit because I did not start and end at the same spot. So I'm going to say this graph does not have an eulerian circuit. So we just said that it has an eulerian path. It has 2 vertices of odd degree because that's the starting and ending point. So to have an eulerian circuit, you need to have all even degree. It does not have an eulerian circuit because there are vertices of odd degree. So in order to have that circuit, you need to have all of them be even degree. Let's look at this example. So here's a graph. You want to know, does this graph have an eulerian path and or a circle? So just to review, if it has all even degree, it has an eulerian path and an eulerian circuit. If it has exactly 2 vertices of odd degree, it'll have an eulerian path. And if it has more than 2 vertices of odd degree, it'll have neither. So I'm going to go through and label the degree of each. So this one has 2, 2, 2. This middle one has 4, 4, 2, 2, 4, 4, 2, 2, 2. All right, so this one has all even degree, so it has both path and circuit. Again, the path just ends at two different spots, but doesn't have to. So if it ends at the same spot, it's a circuit, and it's also technically a path.